My name is Casey Hine, and I am a member of Section 3, Team 2, and this is our UAV Lab video journal. Throughout the past few weeks, our team completed 3 labs which built up the core systems needed for autonomous vehicle driving using the JetBot platform. In Lab 1, our team focused on how to control the JetBot using Python and Jupyter Notebook. We programmed basic movements like moving forward, moving in reverse, turning, and rotating in place. We also calibrated the wheel speeds and accounted for motor bias so that our robot could actually drive straight. All of this combined using forward and inverse kinematics allowed us to program the robot to move to specific positions and orientations. For Lab 2, we moved from basic movements to closed-loop autonomy. Using the JetBot's camera, our team processed images to detect the road and calculate heading angle. We implemented and tuned a PD controller so that the robot could follow this path smoothly. We also trained a deep learning model using transfer learning to recognize signs. Our team collected image data, trained the model, and tested in real time, adjusting the data set to improve our accuracy. In Lab 3, our team brought everything together. We used network communication between the JetBot and camera bot, calibrated the camera to remove distortion, and used April tags to track the robot's position in real time. Using this location information, we performed path planning and allowed the robot to make navigation decisions like turning left, turning right, or going straight to guide the JetBot to our desired final location. Overall, these labs allowed our team to combine tools such as computer vision, machine learning, and many others which would be used in our final demonstration.
This flowchart shows how a robot autonomously travels from the start location to a goal while following road signs and traffic signs. The process starts by taking inputs such as the map, the robot's current position, and the camera data, which are used for path planning. The path planning module generates the shortest planned path for the robot to follow. Next, the system checks whether the goal has been reached. If the goal is not reached, the robot continues operating through the main control loop. The kinematics blocks uses the robot's previous position and motor commands to update its motion. At the same time, the sign recognition module processes camera images using a trained model to detect traffic signs. Based on the detection sign, the robot can stop or turn around if required. The path following module then uses the live video feed and path coordinates to keep the robot aligned with the road. This loop continues until the goal is reached. Once the robot reaches its destination, the program ends.
For the JetBot demonstration, we were required to complete a series of tasks maneuvering the JetBot around this road system. In the final presentation of the robot, it needed to complete at least 2 of the 5 objectives given. We decided to show path following, sign recognition, kinematic abilities, and path planning. The bot follows a path around a bend, stops when it recognizes a stopping at a corner, a stopping sign, and then goes forward and turns 90 degrees to the right onto another road. As we prepared the JetBot for the final demonstration, we ran into roadblocks and system issues with the bot. The code had bugs, the JetBot's motion was inconsistent as it moved around the track, and many variables needed different fine-tuning. But after many hours of troubleshooting, testing, and trying different numbers, our bot was able to complete the final tasks well and gain consistently for the final demonstration.
Overall, this project ended up being a fantastic learning opportunity for all of us. Obviously, the hard skills that we gained in terms of being able to use the JetBot and program in Python and all that are fantastic, but the resilience that we needed to show, I think, was really what mattered. There are a lot of times where things did not work out the first time that we tried them, the second time, or even the third time. But being able to go through our steps, find where we went wrong, look back, and tune everything to completion, when it all came together in the end, it was a uniquely satisfying experience. I think I can speak on behalf of the whole team that I'm really glad we were able to do this and see it through the end.